Now next question. In an elastic system, the external work done by a force Pi during the deformation caused by another force Pj is equal to the external work done by the force Pj during the deformation caused by Pi is stated by, this is stated by the Maxwell-Betty theorem. What it says, suppose there is a beam, the external work done by a force Pi during the deformation caused by another force Pj. So this is the force Pi, another force is Pj, and due to this force there was a displacement, and the displacements are, and this displacement, and under this displacement is, displacement caused by this force Pj, therefore delta J. The displacement under this load, we can take it as the displacement which was caused by this Pi under Pj load, that is delta I. Maxwell-Betty's theorem says Pi, that is this Pi into delta J, which is equal to Pj into delta I, meaning the work done caused by load and deformation caused by Pj under Pi, that is Pa into delta J, is equal to work done at J point due to Pj and deformation caused by Pi under Pj. So you can multiply work done is equal to force into distance this one, force into distance this one. What is this delta J? Delta J is equal to deformation under force Pi due to force acting this point. Due to this force, the deformation delta J. Due to this force, deformation delta I in this point. Then we can use the energy principle, load into deformation. So that is a thing which was said by Maxwell-Betty's theorem. Okay. So answer is C. Now next question. A simply supported beam of span 24 meter is to be designed to carry a central concentrated load of 200 kilonewton. If a 40 meters and 40 centimeters a dip of the cable at the loading point from the neutral axis, the effective pre-stress is. They are asking effective pre-stress. A simply supported beam, they said. A simply supported beam of 24 meter span. The span is 24 meter. Designed to carry a concentrated load of 200 kilonewton. A 40 centimeter dip of the cable at the loading point. So this is the neutral axis point. Under the loading point, there is a 40 centimeter dip. The 40 centimeter dip of the cable at the loading point from the neutral axis. Then the effective pre-stress, this is the cable, okay? Then the effective pre-stress that was applied P. Okay, applied P. Now we know that the concept, moment due to this P at the center, that is P into E, load into this eccentricity, which is equal to moment due to this point load, that is WL by 4. That is P into 0.4 is equal to 200 into 24 divided by 4. So this we can take it as 6, right? 6, 1200 divided by 0.4 is equal to P. For P is equal to, we can take, calculate, we will get a 3000. 3000 kilonewton. Therefore, answer for this question is B. Okay. Next question. The batten plates used to connect the components of built-up column are designed to resist. This is the factual question. Answer is C. It is used to resist the longitudinal shear and moment arising from the transverse shear. We know that the batten, so this is the one column element, this is the another column element. These two column elements are held together by using the batten. So this arrangement is called a batten, and this batten is designed for longitudinal shear and moment arising from the transverse shear. So this is the factual thing, so you have to keep in your mind. So this is the batten. Okay, next question. The steel plate is 300 millimeter wide, 40 millimeter thick, is designed to connect using 24 millimeter dia of bolt of 3 numbers. The net cross-section area of the plate is, the net cross-section area of the plate is calculated as, so this is the breadth of the plate. The breadth of the plate is 300 mm. And a net cross-section area of the plate they are asking. But there are 3 bolt which was used. 1, 2, 3. At this section, what is the net cross-section area of the plate? What is the net cross-section area? And they said there was a thickness of 40 mm. So this thickness is 40 mm. So at this point, the net cross-section area A net is equal to total breadth minus number of bolt into diameter of bolt hole into thickness. Here, there are 2 things you have to remember. For a rivet, up to 25 mm size, diameter of hole, you know, this is D plus 1.5. Greater than 25 mm, so this is up to or less than or is equal to. This diameter of the bolt hole is less than or is equal to, diameter of bolt is less than or is equal to 25 mm, then you have to add D plus 1.5. Greater, then you have to add D plus 2. This is for a rivet. Okay, this is the concept for rivet. Next one is a bolt. For bolt, there are sizes 12 to 14 mm, 16 to 24 mm, greater than 24 mm. Diameter of bolt hole is equal to D plus 1, D plus 2, D plus 3. You have to add 1, 2, 3. Diameter of hole is calculated in such a way that. But now here they given the bolt, right? Therefore, what is a B? 300 minus what is N? 3. Number of bolt hole is this the 24 mm diameter. Therefore, it is comes here itself, right? Therefore, 24 plus 6 into T. T is equal to 40. So the answer for this question is 300 minus if we simplify this, sorry, this is not 6, right? 2, 24 plus 2. So 26 into 3, 300 minus answer into 40. So you are getting 8880 millimeter square. This is A net actually you will get. But you don't have answer. 880. We don't have answer. Okay. But I also checked this by considering instead of bolt, I consider the rivet. But this question is somewhat vague in nature. As per my perspective, this question is wrong actually. Okay. As per my perspective, this is wrong. But anyhow, I solved this question by considering instead of using bolt, I considering this is the rivet. Now A net is equal to 300 minus 3 into what is the diameter of the hole? 24 into up to 25. Up to 25, you have to add 1.5 only. Therefore, into this is 40. So therefore, 300 minus 3 into 25.5 into 40. So the answer is 3 into 25.5. 300 minus answer into 40. Now here you are getting 8940. Getting 8940. So now your answer is 8940. So that is this. So this is the answer you are getting. So we are getting, if we consider this as a bolt, sorry, rivet. But if we consider as a bolt, then you have to add a size. You have to add 2 with the diameter of the bolt, so that you will get a 26. So 26 into 3, 26 into 3, 300 minus answer into 40, you are getting 88,880. But such option is not there. 8880 is not there. But if you use this 1.5, that means by considering a rivet instead of bolt, then you will get an answer. Sorry, not a D. Answer B you will get, right? B 8940. Okay. Again, I am saying this question is not perfect. This question is not perfect, somewhat vague in nature. But anyhow, you have to attempt this question. Maybe if they found the question which was taken is wrong, then they will give the mark. Okay. Next one. The use of concordant cables in pre-stressed continuous beam, which indicates or which induces on the beam no initial support reaction. So this is the answer for this question. So I can write you the concordant cable profile means I can write concordant cable profile. It is the profile of statically indeterminate pre-stressed concrete beam corresponding to which no secondary stresses. There is no secondary stresses and support reactions reactions develops. develops in a structure. It is an unique profile. It is a unique profile which is derived corresponding to bending moment diagram. So the general meaning of this concordant cable is, suppose this is the continuous beam, and this continuous beam is having a load UDL acting throughout the span. Then the bending moment diagram is something like that. This is the bending moment diagram. If you provide the cable in the shape of the bending moment diagram, then there is no support reaction and the secondary stresses comes into play. Only the cable is subjected to stress. Okay, that means if you provide the cable in the shape of the bending moment diagram, then the beam will not subjected to secondary stress and the support reactions. Okay, therefore the answer is no initial support reaction is the answer. Next question. The losses in pre-stressed in pre-tensioned beam are more than the losses in the post-tensioned beam due to. So answer for this question is A. Let me explain this. There are two losses in pre-tension member and post-tension member. First one is, we can write short-term loss, short-term, another one is long-term, another one is long-term loss. Then what is a short-term loss? The first one is elastic shortening of concrete. That's the first one. Elastic shortening of concrete is a short-term loss. Second one is anchorage slip. Third one is friction. So these are the examples for short-term losses. Long-term losses, creep of concrete, and shrinkage of concrete. This is one long term. Next one is relaxation of steel. Okay, so these two are the short term and long term losses. Further, pre-tensioning and post-tensioning. Pre-tensioning and post-tensioning losses. What are the losses? The first one is elastic shortening of concrete. Elastic shortening of concrete. That is the first one, elastic shortening of concrete. The second one is creep and shrinkage of concrete. Shrinkage of concrete. Third one is relaxation of steel, also called as creep of steel. This is the pre-tensioning member. Then post-tensioning member, be careful. One, losses due to elastic shortening of concrete is not present. Elastic shortening is not present. Elastic shortening is not present. Okay, not present. We can write some more in case of simultaneously tensioning. Simultaneous tensioning, there is no loss due to elastic shortening of concrete under post tensioning. Okay, but it is present in the case of successive tension. And second one is all other losses. This second one. Now see, generally for post tensioning, loss due to elastic shortening of concrete is not happen. Now you can see the question. Losses in pre-stress, pre-tension beams are more. Yes, pre-tension beam is more than losses in the post-tension beam due to elastic shortening, because in the pre-tensioning member, one quantity also additional, that is a elastic shortening due to concrete. But the elastic shortening due to concrete is not happen in the post-tensioning. This is the reason for post-tensioning member, for pre-tensioning member, the loss will be more. Understood? The loss will be more. The reason is effect of elastic shortening. Next one is, a steel beam is replaced by a corresponding aluminum beam of same cross-sectional shape and dimension and is subjected to same loading. Everything same. Only the material properties differed. The maximum bending stress now will be, we know that M by I is equal to F by Y is equal to E by R. You can compare these two equations. Here F is a bending stress. F divided by Y is equal to E divided by R. Now there are two beams, right? Now the bending stress is varies directly proportional to the Young's modulus. So we can take D is the answer. Vary in proportion to their modulus of elasticity. Okay. Now the next question. The base plate of your roof truss is attached to the concrete pier with the help of a 16 mm diameter anchor bolt. Be careful. The bolt is anchor bolt of a grade Fe 250 megapascal. What is the maximum pull that can be subjected to if the root dia is 0.75 times the shank diameter? Okay, therefore we can calculate the P is equal to the base plate of the roof truss is attached. So this is the base plate is attached to the concrete pier. So let us consider this is the concrete pier with the help of 16 mm diameter bolt. There's 16 mm diameter bolt. Of grade Fe is equal to 50 megapascal. What is the maximum pull? The base can be subjected if the root dia is 0.75 times the shank diameter. So we know that because of the load, this bolt is now subjected to bearing action. Okay, because this base plate produces the bearing force on the pier. So this bolt also now subjected to bearing force. Okay, therefore we can write force equal to stress into area. What is the bearing stress? 0.75 into Fi. That is a bearing stress. And the area is equal to, they said, 0.75 times the diameter of the sign. So here the diameter of the sign, that is given how much? 16, right? Diameter of the bolt. For 5 by 4 into 16 square. So if you simplify, 0.75 into 250 into 0.75 into pi by 4 into 16 square. So while simplifying this, 0.75 into 0.75 into 250 into 16 square into, so divided by 4. So we will get, the answer is equal to 28274.33 Newton. In terms of kilonewton, how much? 28.3 kilonewton. So this answer is B. Okay. So answer B is correct. Now we can go for next question. The behavior of an over-reinforced beam is more ductile. Actually, the over-reinforced beam is not actually ductile. Over-reinforced beam is more ductile. No, over-reinforced beam is not more ductile than that of under-reinforced beam. Under-reinforced beam. No. Over-reinforced beam is brittle actually. Under-reinforced beam is ductile. So because of this, the statement is wrong. Okay. This is the thing. And next one is the load carrying capacity of a column designed by working stress method is 500 kilonewton. Then the ultimate load of the column, that is ultimate load of the column is equal to, factor of safety is 1.5 into 500. So is equal to 750. So answer for this question is this one, 750 kilonewton. Now next question. As per IS 3370 part 2 2009, concrete structure for storage of liquids, you can call it as this a water tank. The permissible stresses in steel reinforcement for the strength for high strength of deformed bar, HOST bar. You know, permissible stresses for steel, for mild steel, your value is 115 Newton per millimeter square. For HOST bar, the value which is taken as 130 Newton per millimeter square. Then for concrete, it is taken as M25, M30. Okay. This is for direct tension, bending tension. Direct tension, bending tension. So this direct tension, this value is 1.3, 1.5. For bending tension is 1.8, then 2. So this is the answer. This is Newton per millimeter square. This is also Newton per millimeter square. Newton per millimeter square. So answer for this question, HOST bar permissible stress is 130, right? Now next one. The torsional reinforcement for a corner held down in the slabs are provided. The corner reinforcement or torsional reinforcement will be provided for discontinuous edges. Suppose there was a slab on a frame. This, okay, and see, this corner point is a discontinuous. So beyond this point there is no continuity, and from here beyond this point there is no continuity. Therefore, in this portion, I'm saying in example here, or we have to provide a corner reinforcement or torsional reinforcement. You have to provide by a percentage of 75% of maximum bending moment. You have to provide 75% of reinforcement at this point. Okay, the torsional reinforcement for corners held down in the slabs are provided discontinuous edges. Be careful, discontinuous edges, not a continuous edge. Next one. The side face reinforcement is provided when the depth of the web of the beam exceeded 750. The thing is, as per in RCC, as per IS 456/2000 in RCC, if the depth of the web is greater than 750 mm, if the depth is, this is the depth of the beam, greater than 750 mm, then you have to provide a side face reinforcement. We have to provide a side face reinforcement. Provide a side face reinforcement of an area of 0.1 percentage of gross area of web, gross area of web, equally distributed on both sides, equally distributed on both sides, and the spacing shall not exceeds 300 mm. So this is for RCC. And in pre-stressed concrete structure, in pre-stressed concrete structures, in pre-stressed concrete structure, this value will be used when the depth of the beam is greater than 500. When the depth of the beam is greater than 500, then we will use the side reinforcement. But in the RCC, we will use the side reinforcement when the depth of the beam is greater than 750. Next one is, the depth of footing shall be designed for, very, very important, this is the factual thing, design for a shear, check for a bending moment. That means footing design, footing can be designed for a shear and check for a bending moment. Bending moment check. There are two types of shear. One is one-way shear, another one is two-way shear. Another one is two-way shear. One-way shear is found by a distance of d from the face of column. But a two-way shear, which is determined d/2 distance, d/2 from the face of column. Understood? That's the difference. So answer is C, correct. The next question, as per IS 1172-1993, in the design of water supply scheme for a town with a full flushing system. Full flushing system means the peoples, those who are living on that particular area, use high amount of water, meaning there's a high income group peoples or high standard peoples. Okay, full flushing. The minimum water supply for domestic demand is 200 LPCD. Generally, the people will use put this 135 LPCD. Be careful, this is the full flushing system, 200 LPCD. Okay, as per IS 11721993 says 1993 says low income group peoples, high income group peoples, domestic demand. So what is the value of domestic demand? Low income group, high income group. Domestic demand. Next one is industrial demand, commercial demand, public demand, public use demand, waste due to theft and leakages. And the last one is fire demand. And these values are domestic demand, fire demand, industrial demand, commercial demand, public use demand. So the domestic demand, the value is 135. For high income group, this is 200 LPCD. So fire demand always less than 1, always less than 1. Industrial demand 50, 50. Commercial demand 20, 20. Public use demand 10, 10. Water losses due to theft and leakages 55, 55 LPCD. So the total water demand for low income group is 270. This one is 335. Footnote. For full flushing system, domestic demand is equal to 200. This is the full flushing. The high income group people only use full flushing system. For partial flushing system, domestic demand is equal to 135 LPCD. But in general, if they ask, without giving full flushing system, if they ask generally, what is the domestic water demand of the village of Indian condition? If they ask generally, then you have to take 135. Okay. In India, maximum water demand is equal to 335. That is a maximum at most LPCD. Okay. So the answer is here, full flushing system 200. Next one. The safe permissible limits of nitrate in the water supply is 45. Here the nitrates is 45 ppm. Nitrite is 0 ppm. So this is important because nitrite is the poisonous in nature. So we should not encourage the value. Next one. The settling velocity of an inorganic particle in a sedimentation tank of water treatment plant is governed by. Is a very simple direct question, Stokes law. Yes. The self-cleaning velocity for all sewers in India is. This also direct question, 1 to 1.2 meter per second. Next one. The relative stability of a sewage sample whose dissolved oxygen is same as the total oxygen required to satisfy BOD is. The total oxygen required to satisfy BOD is. We know that a relative stability, the formula is ratio of oxygen available in the effluent, oxygen available in the effluent as dissolved oxygen, oxygen available in the effluent as dissolved oxygen to total oxygen required, total oxygen required to satisfy its first stage BOD. Now you can write what is the rate of stability. This is oxygen available in the effluent. Here, CV sample whose dissolved oxygen is same. That means this numerator is same as the total oxygen required to satisfy the BOD. Therefore, if you consider this as a X and this also you can consider X, both are same into 100. Therefore, answer is 100%. So answer for this question is in terms of, you can write 100%. And the relative stability, some formula is there. You can write this is SR. Relative stability we can write is equal to 100 into 1 minus 0.794 T20. Relative stability is equal to 100 into 1 minus 0.630 T37. This is time in days for 20 degrees Celsius of test run. This is the 30 degrees Celsius of test run. Time in days. This is their formula. So this also may be direct equation they will ask you in the examination. Okay. Next one. In a sewer carrying a discharge of 3 cubic. So sewage discharge is equal to 3 meter cube per second. Outfall into a river having a discharge of river discharge. Q river is equal to 10. And dissolved oxygen of river is equal to 9.1 milligram per liter. But here the oxygen of sewage is equal to 0. As per this, there is no oxygen given. Then the resultant concentration of the mix they are asking. Concentration of dissolved oxygen. We know that the concentration of dissolved oxygen or resultant dissolved oxygen can be written as QS into OS plus QR into OR divided by QS plus QR. So is equal to 10 into 9.1 divided by 3 plus 10. So is equal to 91 divided by 13. So answer is 7. So 7 milligram per liter. This is the concentration. Okay. This is the equation, concentration equation. Be careful.